main gym, angkat berat dan sebagainya. Okay, that is what we mean by strength training. Although these two modalities represent the extremes of a continuum of exercise protocols. Kita ada dua jenis, and in between tu dia adalah mungkin ada yang buat endurance and ada juga yang buat strength training at the same time kan. But in general these are the two extreme lah. One end we have endurance and at the other end we have strength. But in between tu can you think of ada tak sukan yang kita buat dua-dua? Ada endurance and ada strength. What do you think? Any type of ni yang you rasa kita ada dua-dua? What do you think? Any sport yang ada combination of endurance and strength? Rugby lagi. Weightlifting. Weightlifting more like a resistance. Swimming more like endurance. Football more like endurance. We call it like a intermittent kind of sport lah. Football ni. Sebab dia ada berlari, dia ada jogging sekejap, dia ada stop sekejap. So we call it intermittent lah. Triathlon, mungkin yes, triathlon. Mungkin strength lah. Strength ni involve something like I would say like macam tarik tali. Tarik tali ni more like strength lah. Wall climbing, more like strength, endurance, something macam tu lah. Saya rasa more like orang kata apa, kalau cross country, wall climbing kan, cross country, kalau tengok cross country, you perlukan strength kan untuk you climb the hill for example, hiking for example. Itu more, I mean in between tu kita ada lah sukan-sukan yang mungkin a combination of these two. Right, dan kita akan tengok lah what happen kalau kita do endurance training, ada molecular level. And also what happen kalau we do a endurance training. Kalau kita buat dua-dua macam mana? What happen? So we are going to look today. Right, and then regular endurance exercise result in an increased expression of slower myosin. Myosin is actually a muscle fiber kan, we call it myosin. Ada kan you all belajar kan dalam you all punya physiology, anatomy and physiology kan. Myosin kita punya muscle fiber kan, nama dia myosin. Associated with fiber type shift towards the type 1 phenotype. Maksudnya untuk endurance ni kita dia more like they looking at the slower myosin. They're not looking at the fast twitch punya muscle, but rather when you do the endurance ni you improve ataupun they increase the expression of slower myosin type of fiber lah, muscle fiber. Right, and then the lag time for these changes may be about 1 week. And then the fiber cross-sectional area is scarcely affected. Maksudnya dia tak ada memberi kesan lah terhadap kita punya orang kata the thickness lah, the thickness ke the area orang kata the ketebalan kan, cross-sectional area of kita punya muscle tu. Whereas muscle capillarity, maksudnya inside the muscle tu, muscle capillarity is enhanced. And the number and size of mitochondria increase. It does not affect the area lah ataupun the physical features of kita punya muscle tu, but rather they increase muscle capillarity and the number and size of the mitochondria in the muscle cell. This is what happen lah. Right, and then conversely, tadi for endurance, kalau strength ni the effect dia is in another way around lah. For the strength training, it has a greater effect on the muscle fiber cross-sectional area. So kalau you buat strength kan, dia macam tadi tu dia more like a slower type of myosin kan, and they increase the size and numbers of the mitochondria. But for the strength ni, there is more effect on the increase muscle fiber cross-sectional area, mainly due to an increase in the number of myofibrils. This is what happened. So during these two type of exercise, different things happening or in our body lah. Right, and then mitochondria and capillarity are little affected as opposed to the when we perform the endurance exercise. As the different changes indicate a specific adaptive mechanism underlie this phenomenon. So maksudnya kita ada something lah yang regulate Okay, now for the first one, we look at the molecular mechanism underlying the metabolic effect of exercise. We look at the endurance training. And then previous study show that evidence of the transcriptional regulation of several metabolic genes. So when we talk about genes, of course berlakunya transcriptional lah. This is what happen, transcription. Maksudnya benda-benda yang mempengaruhi the regulation of gene lah. To what we call transcriptional regulation of several metabolic genes in response to endurance exercise. Right, in this regard, in this punya in this context, we are talking about the mRNA lah, messenger RNA. M tu stand for messenger, we call it mRNA ataupun micro RNA lah, of mitochondrial proteins encoded both at the mitochondrial and at cellular level. So this one at the mitochondrial and cell at the nuclear level ni, we cannot see kan with our naked eye. Kita kena tengok bawah electron microscope. It's very detailed microscope. Then only we can see the mitochondria and also the nucleus, for example. Was found to be increased to a similar extent. How much is around 1.5 to 1.9 fold of the protein encoding for the mRNA. Right, and then a number of mechanisms may be involved in initiating this genomic response and may participate in the adaptation to the endurance training. Right, and then there are the few listed below. Kita ada a few lah yang regulate during endurance training. The first one macam like we discussed before, ATP consumption with the subsequent increase in the AMP. What is AMP? Adenosine monophosphate kan. Kita ada juga AMP, lepas tu kita ada apa ADP kan, adenosine diphosphate and adenosine triphosphate kan. Kita ada 3 jenis kan. Right, increase in the AMP production. And then this activates the 5 AMP activated protein kinase. Kita ada a molecule lah. We call it AMPK. And this AMPK is actually being activated by kita punya AMP. And then this multi-substrate serine threonine kinase directly. So when we talk about kinase, so dia ada ability untuk add phosphate. Kat sini kan, when we talk about kinase here, maksudnya we have the ability to add a phosphate group lah. Directly phosphorylate. So that means this is when we add a phosphate group kan, we call it phosphorylation lah multi-substrate serine threonine kinase. We are talking about this one lah. AMPK ni, dia adalah multi-substrate serine threonine kinase lah. In this regard, we are talking about AMPK. This AMPK is directly phosphorylate peroxisome proliferator activated receptor gamma co-activator, or we call it PIPA gamma. Peroxisome proliferator activated receptor. So this is actually the receptor lah. Co-activator 1 alpha, or we call it PGC1 alpha. For this to happen, sebenarnya AMPK ni dia phosphorylate kita punya PGC1 alpha. PGC1 alpha ni is actually a key activator of the mitochondrial biogenesis program. So at the end or at the cellular level kan, kita ada this lah, this the master or the master regulator ni actually down in our at the cellular level we have PGC1 alpha. What is PGC1 alpha? Peroxisome proliferator activated receptor gamma co-activator 1 alpha. Oh, panjang nama dia but in short form adalah PGC1 alpha. Right, and then this PGC1 alpha is actually being phosphorylated by kita punya AMPK. So you nampak dalam ni dia ada banyak benda yang involve signaling kita what we call a signaling molecule ni is very complex different different metabolism kan in kita punya fat oxidation kita ada different kita ada different saya ada another meeting at the same time So when we talk about apa orang kata, when we talk about uh, in this regard, we are talking about kita punya endurance training kan. So we have a different regulator. When we talk about fat oxidation, kita ada different punya molecular mechanism, different punya mechanism happening at the cellular level. And when we talk about protein degradation, dia ada mechanism lain yang involved. It's actually very complex process lah in our body. So different when we talk about different regulation and different signaling molecule involved. Right? Right, and then in this regard, you need to remember this one lah PGC1, 1 alpha, and then increase what happen next when this is being phosphorylated, and this is the biogenesis, and when this is being orang kata apa, being activated, this PGC1 alpha, and this will increase kita punya cytosolic calcium, cytosolic in the cytosol lah again inside the cell, inside the cell, this Ca2 plus calcium regulate the downstream gene expression mainly through activation of AMPK, right? And then indirect pathway also participates in this process, which is mediated by calmodulin. So banyak benda lah yang berlaku in the system ni, in this very complex system. Right. So dalam ni kita ada apa? What are the keywords? Kita ada AMPK, kita ada PGC1 alpha, and kita juga ada Ca2 plus, and kita ada calmodulin. All this involved. Right. Right. And then what happen next? Apart from kita punya tadi lah PGC1 alpha and so on. Kat mana tadi? Alright, here kan? Right. And then apart from this ni, when we do exercise kan at the cellular level lah sebenarnya, macam kita lah kan bila kita exercise physically, kita nampak kita bila kita doing endurance exercise kan, of course kita akan tercungap-cungap kan, huffing and puffing tercungap-cungap. Itu adalah indication of we need more oxygen lah kan. And then sama juga at our cellular level something happening kan. Physically memang tercungap-cungap. And then maksudnya apa? Inside our body, that means kita punya body tu memberitahu we need something lah kan. We need energy, we need oxygen. Lepas tu kita tercungap-cungap. Okay. And then at this level sebenarnya, ROS production or we call it reactive oxygen species we call it ROS, ROS ke ROS, Kak Ros. ROS production reactive oxygen species production, which increases lah during contractile activity may contribute to AMPK activation. And then prior to the tadi yang kita bincang tadi kan, when we talk about AMPK, there are other things that can activate ataupun that can ataupun stimulate lah kita punya AMPK. ROS ni lah sebenarnya. ROS ni datangnya daripada kita punya cellular metabolism. ROS, reactive oxygen species yang dia it is actually unstable punya molecule lah being produced is actually a byproduct of kita punya oxygen metabolism lah in our cell. Right, and then we have another factor we call it HIF1 which is we call hypoxia inducible factor 1 and this HIF1 actually translocates to the nucleus during cell hypoxic stress determining PGC1 alpha, GLUT4 ni glucose transporter untuk to bring in and out of the glucose molecule lah in our body kan, untuk masuk ke dalam sel kalau if you imagine lah, dalam badan kita, in our body we have a cell kan, for the glucose to go inside the cell and to go outside the cell, we need a transporter kan. Transporter dia nama GLUT4 lah, dia ada banyak lah, different kind of transporter. Kita ada GLUT1, GLUT2, GLUT3, GLUT4, depends on which kind of muscle we are talking lah. Kalau in muscle, biasanya we have the vast majority of it dalam bentuk GLUT4. GLUT4 ni is the major glucose transporter in our muscle punya fiber lah. And also phosphofructokinase gene activation. And then on the top of this, kita ada different lagi kita ada lagi satu, kita ada SIRT1 silent mating type information regulator 2 homolog 1. So macam tu lah, kalau you tengok dekat at the cellular level ataupun at the molecular level, nama dia biasanya panjang-panjang and then nama dia kompleks sebabnya dalam in our body ni we have millions of regulation kan. Sebab tu nama dia panjang, because they want to differentiate from one to the other. Biasanya nama dia tu indicate dia punya function. So kalau tengok macam ni, hypoxia inducible factor 1, this is actually a factor kan. Kalau macam ni you tengok nama dia regulator 2 homolog 1. So dia specific nama dia. Sebab tu nama dia panjang sebab dia try to give a specific function to dia punya name. Sebab tu nama dia panjang. Okay, for the SIRT1, SIRT1 ni is actually being activated by the increase in substrate and AD plus availability and contributes to PGC1 alpha activation. So that means kita ada different kind of thing being activated by different punya signaling molecule lah. Kalau untuk AMPK, kita ada ROS as a activator. Kalau kita ada PGC ni is actually being activated by SIRT1 for example. Right, and then intramyofibrillar availability of FFA. FFA ni what we call is free fatty acid or in textbook they might refer this as a non-esterified NEFA non-esterified fatty acid kalau you tengok, tapi for the NEFA tu biasanya buku yang lama lah, they call it non-esterified fatty acid or they call it NEFA. NEFA. But in the modern punya textbook, they call it free fatty acid lah. They are actually the same thing je, cuma different terminology. Okay, this FFA can actually directly stimulate kita punya PPAR gamma peroxisome proliferator activated receptor gamma PPAR S. S ni why we put it S sebabnya PPAR ni ada banyak. Ada PPAR alpha, beta, delta, gamma and so on. But for the FFA ni in general, they stimulates all PPARs. Sebab tu kita panggil dia PPARs, ada S lah. Kalau macam gamma, we are talking about gamma tadi tu yang PGC1 alpha lah, yang tu gamma. Kalau for the FFA ni, they not just activates PPAR gamma, but all kind of PPAR lah. PPAR ni kita ada banyak, ada alpha, beta, delta, gamma and so on and so forth. Banyak jenis. Sama juga macam GLUT4 tadi, GLUT4 ni samalah macam PPAR ni, dia bergantung dekat which kind of muscle you are talking about. Kalau dekat adipose tissue kita ada PPAR yang lain, kalau dekat muscle pun ada PPAR yang lain, bergantung kepada lokasi ataupun the location of kita punya PPAR tadilah, which are molecular sensors of this substrate. Right, kalau when we talk about free fatty acid ni biasanya datang daripada mana? Kan datang daripada from our diet lah kan, apa yang kita makan. Free fatty acid ni something yang not being bound. Not being bound dalam bentuk molekul lah kan. Kalau yang being bound ni kita ada apa? Kita ada triglyceride, kita ada LDL, lepas tu kita ada apa lagi? IDL, lepas tu kita ada HDL. Lepas tu kalau yang bound to the being sent to the liver, kita ada apa? VLDL kan dan sebagainya. Yang tu all bound type of free fatty acid. But what we are talking FFA ni adalah yang free, yang ada dalam kita punya circulation dalam badan and not being being bind or bound to any other molecule lah. Maksudnya kalau free fatty acid ni dia are readily available lah to be used by our body. Are you okay so far? So good? too fast, too slow, or just okay? You okay? Right, eh? Right, and then in this series of event, again, we are talking about PGC1 alpha acts as the key downstream element of most signaling pathway responsive to endurance exercise stress. Right, in this regard, just remember when we talk about endurance training, you must have in your mind PGC1 alpha. PGC1 alpha ni is actually considered the master regulator yang saya dah mention tadi lah in the mitochondrial biogenesis in skeletal muscle. Then physical activity acutely induces PGC1 alpha, but this effect is only acute, maksudnya hanya bersifat sementara lah ataupun short duration, and inactivity rapidly reduces its concentration. So kalau activity ni maksudnya kita tak buat aktiviti lah kan, kita tidak bersenam, maksudnya kita the level of kita punya PGC1 alpha ni is very very low lah, ataupun dia dalam erti kata lain dia tidak being activated, ataupun dia berada dalam keadaan inactive ataupun dormant, dia tidak aktif, and juga reduce its concern, it can also reduce dia punya concentration. Right, and then to meet increased mitochondrial oxygen demand, the oxygen supply needs to be augmented as well. Maksudnya macam tadi lah yang saya dah cerita tadi kan, kalau kita buat exercise, of course kita akan tercungap-cungap kan. This is a signal lah, send to our body, whether we can do it more or we should stop kan. So kalau kita dah terlalu terlalu cungap sampai tahap yang teruk kan, sangat ekstrim, so that is the signal lah, the first sign that tells our body to stop, ataupun kita kena berhenti. Maksudnya kita tak boleh nak support the oxygen tu. Selagi boleh cungap kan, sampai satu masa, biasanya test yang kita buat ni VO2 max lah, VO2 max, the maximum capacity lah of our lung kan, to consume the oxygen kan, we call it VO2 max. Later on kita akan tengok lah on what is VO2 max. And then accordingly, muscle involved in exercise increase capillarity, yang ni kita dah mention tadi, increase capillarity rather than dia punya muscle cross sectional area during endurance training. In this process, PGC1 alpha again plays a major role, and it is major mediator for exercise induced angiogenesis, right? In this regard, PGC1 alpha induces several angiogenic factors, and then for example, vascular endothelial growth factor, platelet derived growth factor, and angiopoietin 2 lah. This is what we call angiogenic factors. Right. To summarize, Ca2+, calcium signaling and the AMPK system, these two things seems to be the major input determinants ataupun faktor-faktor penyebab lah, of the network contributing to endurance exercise adaptation. Whereas ini yang menentukan lah how we adapt. Kita ada Ca2+ signaling, AA and AMPK system. How we adapt to the endurance exercise, whereas ROS, hypoxia, and SIRT1 may serve to fine tune the response. So kita ada major stimulator, and then kita ada micro stimulator lah kan. So macam tu, kita ada dua benda lah. Kita ada yang main, the master one, which is the Ca2+ signaling and AMPK, and then kita ada benda-benda kecil yang fine tune kita punya respon tadi lah, which is the reactive oxygen species, hypoxia, and SIRT1. Okay, and then put this together, this signaling process is sensitive to substrate availability, in particular lipids. For PPARs, tadi I mentioned earlier on kan, when I mentioned about free fatty acid, is the activator lah for kita punya PPARs, and glycogen for AMPK. When we talk about PPARs, lipid ataupun free fatty acid lah, to be precise, is the activator of the PPAR, and kalau AMPK is actually the substrate that we need for the AMPK to be activated, is the glycogen lah. Okay, so these are the two things. Right. All regulatory pathways converge on transcriptional coactivator PGC1 alpha. And then this specific mechanism happen. Alright. PGC1 alpha is actually what happens. It binds and activates multiple transcription factors and nuclear receptors. And then these can recruit chromatin remodeling complexes. And then the main consequences of which are an increase in the number and size of mitochondria and capillarity. So these are the things that we need to know lah. When we talk about endurance, and the keywords are apa tadi? Ca2+, and then kita ada AMPK, and then kita ada those yang fine tune kan kita punya signals tadi, and kita ada ROS, kita ada hypoxia. Okay. And then at the end, what happened? Actually, we increase the number and size of mitochondria and capillarity lah in the cell. But nothing on the cross sectional area of kita punya muscle, right? Okay, for the second one now, we are going to look at the strength training. Strength training on the other hand, as opposed to the endurance training, dia leads to muscle hypertrophy kan. Trophy ni kita tengok orang kata apa, trophy kan. Kalau hypo, pemecahan lah. Kalau hyper ni kita punya tu dia jadi bigger lah, what we call a hypertrophy. Dia, kita punya muscle tu getting bigger and bigger. The strength training leads to muscle hypertrophy with an increase in the muscle cross sectional area lah. Kita besar, the cross sectional tu getting bigger. Right. Then the increase in muscle volume or mass is fundamentally accounted for by an increase in myofibril, as opposed to endurance lah. Kalau endurance dia increase in capillarity kan, mitochondria and dia punya size kan. And for this one kita increase dia punya kita punya mass lah, ataupun increase in myofibrils. This process is sensitive to sex hormone action lah. In particular, androgens interfere with multiple signaling pathway, stimulating cellular metabolism, enhancing growth, and inhibiting apoptosis. Apoptosis ni is like a natural punya cell death lah kita panggil. Natural punya cell death, sel-sel yang tua, sel-sel yang mati biasanya dia akan dia akan berlakunya proses apoptosis lah ataupun program, we call it program cell death. Call it apoptosis. Androgen replacement is required in hypogonadal men for the increase in the number of myonuclei that underlies the hypertrophic effect induced by strength training. So memang kita perlukan lah androgen ni especially for the hypertrophic effect to happen lah for the strength training. And then the relative composition of muscle in terms of type 1 and type 2 fibers appears to be unchanged after strength training. Maksudnya the ratio tu ataupun the composition tu is actually still the same. But kita increase dia punya size and ataupun dia punya mass lah. However, after resistance training, there is a shift for subtype 2X to subtype 2A fibers. But this just happen on the subtype only, not for the main type 1 and type 2 fibers, but only changes happen at the subtype, muscle subtype, which is 2X and subtype 2A. The regulation of muscle mass depends rather on modification of muscle protein synthesis than on protein degradation. Right. Okay, now we look at the synthesis rate of cell proteins. The synthesis rate of cell proteins in turn depends on both translational efficiency and translational capacity. So we have two things happening, translational efficiency and translational capacity lah. Right, for tadi tu, for the endurance tu, we are talking about PGC1 alpha kan PIPA, gamma, coactivator 1 alpha, or we call it PGC1 alpha. But for strength training ni, kita ada different regulator lah, different things, different punya signaling molecule yang we have. Untuk tadi kita ada PGC1 alpha. Untuk strength training, kita ada mammalian target of rapamycin, or we call it mTOR. M ni stand for mammalian ni, TOR ni stand for target of rapamycin. This mTOR is considered the key factor integrating the multiple stimuli and influencing accretion of myofibrillar proteins and muscle mass hypertrophy. Of course, kan bila kita do different kind of exercise, kan, kalau macam tadi endurance PGC1 alpha, kalau strength, you need to think of mTOR, or we call it mammalian target of rapamycin. Sama juga macam PGC1 alpha and so on. Okay, mTOR ni pun dia banyak jenis kan. mTOR ni dia ada kat different location in our body. Untuk muscle kita ada mTOR, ada different type dia lah. Ada type 2, type 4, type 6 and banyak different subtype. Biasanya dia dibezakan how we differentiate based on dia punya location lah in our body. Right, mTOR is actually highly conserved serine threonine kinase, sama juga macam tadi. Kita juga dia adalah serine threonine kinase which is a major regulatory protein for a number of cell processes. mTOR ni dia not limited lah to a single process but they involve in the cell proliferation, kan, macam mana sel kita tu proliferate, and then cell growth kita perlukan mTOR, cell differentiation kita perlukan mTOR, when we want to synthesize the protein also we need mTOR, and also in the substrate metabolism also we need mTOR. So sebenarnya when we talk about signaling molecule ni dia macam tu lah, dia ada different subtype and then one single molecule they can involve in many pathway, like in this case mTOR ni dia not just involved in the protein synthesis but also in the cell proliferation, kan, pembahagian sel, cell growth, perkembangan ataupun pertumbuhan sel, pembahagian sel dan sebagainya, and also in the substrate metabolism. And then the other thing is mTOR is actually has been established both as a component of insulin cascade and an insulin independent nutrient sensor lah. Right. So kita tengok mTOR ni not just dalam cell metabolism, dia juga involved dalam insulin cascade. So kalau tengoklah, sebelum kita dapat even long before we use our insulin, kan, sebenarnya insulin tu hormon, kan. Hormon ni perlu disintesis in our body, kan. So they involved in the cascade. So that is what we mean by insulin cascade. Before we get the insulin tu, kita ada pro-insulin. Lepas tu barulah jadi kita punya insulin yang aktif. Kalau semua insulin aktif, susahlah kita, kan. Habis semua glukos disimpan in our body, kan. So sebenarnya sebelum insulin tu aktif, dia ada dalam bentuk yang tidak aktif. Kita what we call it as pre-insulin ataupun pro-insulin. Kita ada C-peptide dan sebagainya. mTOR ni it also involved in the insulin cascade and an insulin independent nutrient sensor. This is another function lah of kita punya mTOR. Right. Okay, mTOR is actually regulate muscle protein synthesis. When we talk about kita punya strength training lah. Kalau when we talk about strength training, mTOR ni dia actually regulate kita punya muscle protein synthesis. So kalau once kita regulate ataupun kita synthesize kita punya protein, kan, in our muscle, kita akan increase lah kita punya muscle mass, kan. Logically kita akan increase our muscle mass lah. Why? Because it increase in muscle protein synthesis in response to exercise and nutrition, and also in muscle intracellular signaling. This mTOR actually integrates input from insulin and growth factor signaling, amino acid availability and energy status, leading to protein accumulation of the myofibrillar contractile apparatus. So there is a very complex process happening because this protein they actually get the input from many other factors lah, insulin, growth factor signaling, amino acid availability. Of course, kan, kalau nak synthesize kita punya protein, kan, kita perlukan dalam bentuk amino acid. Again, this factor determines how this mTOR can regulate lah. Bergantung juga pada how many amino acid yang kita ambil, kan. Kalau you do strength training banyak, kan, tapi kalau you tak ada ambil enough amino acid, tak guna juga. Why? Because this mTOR, for this mTOR to function properly, dia juga bergantung pada amino acid availability. Bergantung juga pada your energy status, kan. You buat strength training tapi you tak ambil energy, macam mana you nak develop you punya muscle, betul tak? Contohnya. all these factor actually they comes together lah, for us to increase lah in our to increase our muscle mass ataupun the myofibril contractor punya muscle lah. Right, and then in response to mechanical lah stimuli, so this one kalau those yang buat strength training lah, kalau strength training kan, mechanical stimuli ni maksudnya pergerakan kita lah, mechanical kan, and muscle are capable of generating insulin like growth factor, even bila kita buat pergerakan mechanical ni, our body ni sebenarnya dah ada capability, our muscle ni specifically kan, dia ada capability to increase the IGF-1. What is IGF-1? Insulin-like growth factor 1. So this is by we are not talking about nutrient pun. We are talking about now mechanical stimuli lah. Bila kita buat strength training, maksudnya kita punya muscle tu dia are being capable lah to produce ataupun to generate kita punya IGF-1. Okay, what happened to the IGF-1? IGF-1 ni actually stimulates its own receptor on the cell membrane. So tengok, quite unique kan? Dia tak involve orang lain. Dia actually stimulate its own receptor kan? Macam kita ni, macam kita makan nasi sendiri lah kan? So kita makan nasi sendiri guna our own tangan. Sama lah macam IGF-1 ni. Dia tak swap orang kan? Dia swap diri dia sendiri. Contohnya lah, kalau tengok budak-budak kan, tak reti makan, mak, ayah, kakak, abang kena swap kan. Tapi IGF ni dia macam tu jugalah, dia dah boleh swap diri sendiri kan. Dia can stimulate its own receptor on the cell membrane, and then this follows by activation of several intracellular signaling pathway. Alright, for the IGF ni, apa dia punya effect? Mainly on phosphatidylinositol 3 kinase, or we call it PI3K, PI3K, phosphatidylinositol 3 kinase, protein kinase B. Sama juga tengok, it's a long name PIK ni satu nama. Kalau dia attach dengan protein kinase B, nama dia AKT. So ni nama short form dia lah. Nama dia phosphatidylinositol 3 kinase, PI3K. Kalau dia attach dengan protein kinase B, nama dia AKT. mTOR pathway. So it's very complex punya signal lah ataupun molecule, because PI3K ni dia ada pula protein kinase B, and then dia juga ada mTOR punya pathway involved. These things being actually activated or stimulated by kita punya IGF-1. Then this is considered the main pathway by which muscle protein synthesis is activated in response to growth factor. Growth factor ni we are talking about IGF-1 lah insulin-like growth factor 1. By doing just a mechanical punya stimuli lah. Right. Okay, this is AKT protein we are talking about this one lah tadi AKT PI3K protein kinase B. And then proteins are a family of serine threonine specific kinases lah daripada tadi pun even before that mTOR PGC1 alpha also a kinase. AKT activation induces muscle hypertrophy through downstream signaling and is the dominant positive regulator of mTOR. AKT ni in turn dia regulate kita punya mTOR lah, mammalian rapamycin tadi lah. And then it also inhibit the induction of atrophy signaling. Maksudnya kalau dia tengah berlakunya hypertrophy, automatically dia akan shut down dia punya atrophy. Atrophy ni maksudnya pengecutan lah kan, atrophy kan. Hyper ataupun atrophy. Atrophy ni maksudnya pengecutan kita punya muscle tadilah. It also, dia sebenarnya activate, AKT ni dia activate kita punya mTOR untuk hypertrophy, for the muscle hypertrophy, and at the same time they shut down, inhibit the induction of atrophy signaling. Right, and then interestingly mechanical load per se, maksudnya kalau kita when we look at the mechanical orang kata apa, mechanical punya stimuli alone lah not combining with others, appears to be sufficient to activate mTOR. Maksudnya, in other words, kalau kita buat apa ni, mechanical punya exercise ataupun strength punya training sahaja, okay, is actually sufficient to activate mTOR. Okay, untuk activate sajalah mTOR. And mTOR activation can occur in PI3K independent manner. Walaupun PI3K tadi kan, AKT tadi tu, it can activate the mTOR, okay, but the mTOR ni dalam keadaan certain condition, it can also be independent of the PI3K lah. Okay, the mechanoregulated ni maksudnya mechanical punya stimuli lah. Regulation yang being stimulated by mechanical punya factors lah. Similarly involved in the muscle potency implies a cytoskeletal contribution in which focal adhesion kinase has been shown to play a role. Furthermore, kita bagi mechanical punya force ni may also enhance phospholipase D activity with increased intracellular level of its product phosphatidic acid. This is just another mechanism lah. Right, and then this later may induce sustained activation of mTOR by a PI. Ni bukan PIK3 PI3K ni terbalik typo kat sini. PI3K AKT independent pathway. So kalau dia nak jadi independent, dia kena guna ada means lah. In this case ni, dia guna by this focal adhesion kinase. Kalau dia tak pakai PI3K ni, dia kena pakai focal adhesion kinase. So our body ni, we have a different mechanism lah. Either we are using PI3K or we can use focal adhesion kinase. But there must be a thing lah that can stimulate. Kalau duduk saja macam tu, dia tak boleh stimulate lah something to happen kan. You must have a factor or you must have the stressor lah, for the signaling to happen. This latter may also induce sustained activation of mTOR, like I mentioned tadi lah, by PI3K AKT independent pathway. Right, now what happened? Are you okay? So far so good. Can we take a short 5-minute break? Boleh? Before we continue? Boleh? Senyap je ni. Baru dengar. Boleh? Kita take a short break 5-minute break. We will continue at around 3:33. Now 3:28. We're going to continue at 3:33. Okay? Right? See you. Betul. I think that's a good punya ni lah outcome. Kalau you can combine, maksudnya you ada tengok apa ni substitution ni outcome dia ada dua. So lebih jelas lah. Maksudnya you punya independent variable, and then you ada you punya material tu apa, which is the chocolate lah, and then outcome apa. So kalau you tengok the good title lah, you ada independent, you ada apa ni independent dengan dependent punya benda lah dalam you tajuk dengan material apa yang you pakai. So dalam your case ni, tengok coklat, lepas tu dia punya independent dia adalah apa ni ingredient substitution, and then dia punya dependent adalah outcome lah, glycemic response dengan sensory. Dua. Okay? So I think that's very very orang kata apa nice title lah ataupun cantik lah dia punya title tu. Right, good. Boleh. Hello? Dengar? Dengar tak? Ha. Ha. Ya. Shavita nanti Shavita more akan buat on dark chocolate and disease lah. Dia punya tu memang dark chocolate dengan outcome dia adalah disease. Disease tu metabolic syndrome lah. Tengok on blood pressure, dia tengok on glycemic, lepas tu lipid profile. Hmm. Uh-uh. Uh-uh. Ya, betul. Cuma ni nanti Anis akan jadi expert lah, expert untuk ingredient apa yang nak pakai kan. So nanti Syabinta, she will get the benefit lah from your info ni. So kalau Syabinta nak tahu, Anis, apa ingredient the best kalau nak buat coklat, so dia akan bagi tahu lah, oh kita pakai koko banyak ni, gula kita pakai banyak ni, you faham tak? So you complement each other lah. Okay? Sebab Syabinta dia memang dah detail lah, hanya fokus on orang kata apa dark chocolate kan. So dia tak tahu dah about milk chocolate, dia tak tahu buat chocolate pun mungkin Syabinta don't know kan. So you are the expert untuk buat formulation. So Syabinta ni more like ambil dia punya apa ni, the best ingredient yang you punya ini untuk test on animal. Faham tak? Macam tu lah. Tapi simple je kan proposal untuk apa ni PPS kan? You rap. Boleh lah, boleh. Proposal sekali you rap. Sebenarnya boleh. While waiting tu maksudnya sekarang ni dia sebenarnya UREC tu boleh buat sekali dengan review je. Sebab information yang you guna untuk UREC sebenarnya datang daripada you punya review jugalah. Nampak tak? Sebenarnya UREC tu apa doktor? UREC tu yang untuk human study, yang ethical tu. Sebenarnya bila kita buat review ni bagus ni kita boleh guna untuk banyak benda lah. Review ni kita boleh guna untuk kita punya proposal, review juga kita guna untuk kita punya apa ni UREC application, untuk thesis nanti. Segala-galanya bermula dengan review. Macam tu lah. Okay, saya kena continue saya punya kelas sekejap. Okay, you all bincang lah tapi tengok tajuk dia dah agak cantik dah. Alright. Keep in touch. Later on nanti kita alright, thank you. Bye. Thank you Ani. Thank you Dr. Sah. Bye. Our suggestion topic, the therapy dah improve. Alright, Assalamualaikum and good afternoon lah once again. Welcome back. Sorry, a bit lambat, saya ada another meeting. Saya kena join sekejap lah. Right now, let's go back. Okay, you all, are you still with me? Boleh dengar? Boleh dengar tak? Yes. Ataupun you all dah pergi weekend, dah pergi hura-hure di jalan? You are still with me Good, good. Kita ada berapa? Cuba tengok. Ada berapa orang sekarang? Tengok, saya tak nampak dah pula. Sekejap. Kita ada, oh wow, very good. Kita ada 82. Ada a few lah Ada a few, mungkin ada a few yang, of you yang mungkin tak dapat join. Ada masalah internet dan sebagainya. Nanti kelas rep, you need to let me know lah supaya saya boleh capture. Sebabnya nanti, mana yang tak ada dalam ni nanti sebab attendance tu saya akan ambil automatically daripada Webex ni. Yang you join ni automatic saya akan capture lah you all punya nama. Kalau dia ada masalah, minta let me know lah. Okay. Supaya saya boleh capture you punya attendance tu manually rather than I take from my Webex punya log ni. Right. Right, now let's continue dengan kita punya ni topik tadi. Tadi kita dah tengok untuk effects of kita punya training kan. Training, different training lah. Kita ada endurance and juga strength on kita punya molecular mechanism lah ataupun on the at the cellular level when we do exercise. Okay, now what happened? Tadi kita dah tengok kalau kita buat endurance and strength separately kan. Okay, and then for this one, kalau kita tengok combine training, macam kita bincang tadi lah, ada mungkin certain sport yang kita combine, both strength and endurance lah, macam tadi kan, ada yang cakap apa, hiking, wall climbing, ataupun cross country punya race, kan, you perlukan strength, muscle yang very strong untuk you climb up, dan juga orang kata dengan endurance lah, maksudnya you nak buat tu kan, mungkin nak cross the bukit tu mungkin 20 kilo contohnya, bayangkan track yang you kena lalui tu kan mungkin very orang kata apa penuh onak dan duri kan. So you need a combination of strength and endurance. Okay, what happen when we combine, this will actually result in reduced capacity to develop strength. Kalau kita tengok lah, kita punya, kalau kita combine this ni, kita akan stop kita punya ability untuk develop kita punya strength tu. Whereas it did not compromise the ability to increase maximum oxygen uptake lah, or VO2 max. Okay, in other words, if kita combine strength dengan endurance ni, sebenarnya kita tak dapat sangat effect of the strength tu. Kita tak dapat sangat. Sebab bila kita buat dua exercise, our body ni some sort of dia give us just one option. Either you want to improve endurance or strength. Okay, but unfortunately, our body ni when we do both exercise, dia hanya allow us to effect ataupun improve our VO2 max lah. Kalau kita tengok VO2 max ni more like kita punya oxygen uptake lah. And then dia akan reduce, dia akan reduce kita punya strength capability lah. Dia tak akan improve kita punya muscle strength. Dia hanya improve one. Okay, for example, satu lagi macam when I work previously lah dengan atlet angkat berat, contohnya atlet angkat berat kan, terus yang buat atlet sukma lah, atlet sukma yang berumur sekolah menengah lah, biasanya sekolah menengah, 13 hingga maksimum sukma if I'm not mistaken 21 years old. So kalau atlet sukma ni yang young atlet kan, biasanya kadang-kadang coach minta dia berlari endurance lepas training. Contohnya dia buat pagi, dia ada kalau macam untuk weightlifter dia ada dua training pagi sekali before sebab dia semua ni bukan kanak-kanak apa ni orang kata adolescent lah kan, remaja bersekolah. Pagi dia akan ada training sebelum dia pergi sekolah. So kalau atlet semua ni biasanya dia sekolah sukan kan, MS panggil apa? MSNT kan, majlis sekolah SSKT sekolah sukan apa benda sekolah tu yang dekat Kuala Nerus lah, sekolah sukan yang Kuala Terengganu tu lah So pagi tu dia pergi training, they will have their morning training, lepas tu dia pergi sekolah, petang tu dia akan balik sekolah, siap-siap lunch makan semua, petang tu dia akan ada another session untuk strength. Lepas tu what they did was after the morning, lepas tu afternoon punya training, lepas tu petang tu dia pergi lari endurance. Sebenarnya if dia buat endurance punya running tu, sebenarnya dia won't improve lah dia punya strength, and dia hanya improvekan dia punya cardio. But if dia do the endurance tu too close dengan dia punya strength, so nanti benda tu dia tak dia kena improve lah dia punya muscle tu. Sebab apa? Sebab bila dia buat endurance tu akan stop akan mengganggu dia punya metabolism of dia punya strength yang dia dah buat tadi tu. Alright, so that is something that we need to know lah. For example kan, kalau kita tahu in general kita rasa macam baguslah pergi berlari kan, kenapa tak bagus pula. Sebenarnya it can turn off kita punya strength punya capability tu lah. So this you need to take into consideration later on if you work or if you are dealing with athlete, especially on strength. You need to ask them to go for endurance but not at the same day lah of when they do the strength. Mungkin dia kena buat on other days ke dan sebagainya. Sebabnya untuk strength ni to be activated, sebenarnya dia proses kita punya strength protein synthesis ni dia berlaku dalam tempoh 24 jam. Contohnya kalau you buat strength training pagi ni, so protein synthesis tu dia akan berlaku sampai esok pagi. So maksudnya pagi ni sampai pagi esok. So dalam time frame tu. Kalau dia nak exercise endurance, mungkin dia kena buat petang esok lah. Kan? Bila dia dah allow protein to synthesize and so on untuk develop dia punya muscle, dia petang esok tu mungkin baru boleh suggest dia untuk pergi for endurance lah. Right. Then it can thus be speculated that the AMPK-AKT master switch may be predominate in the adaptive response to the combination of endurance and strength training. So maksudnya kita this pathway lah yang kita akan gunakan Right, and then recent data, recent study show that microRNA, mRNA lah. Tadi mRNA, kalau MI tu kita call it micro. MicroRNA may also have a role in response to exercise training. Actually, Mirna ni microRNA are small non-coding RNA lah. They are quite stable kalau kita when we are dealing with the DNA, RNA ni dia quite orang kata apa unstable kan senang di orang kata apa senang di tempered kita senang contaminate kan kita punya RNA dengan DNA kan. Tapi kalau Mirna ni dia are quite stable. Sebab tu ramai sekarang ni more like to use microRNA lah. Which may play a crucial role in RNA silencing in various regulatory networks. In particular, this specific kind of Mirna lah, Mirna 696 has been shown to be involved in the regulation of PGC1 alpha. So when we talk about this combined training ni, biasanya they have more effect lah on the endurance rather than on the strength. So when we talk about endurance tadi, back to the PGC1 alpha lah. But in this case, kita ada Mirna lah yang 696 yang being shown to play a role in response to exercise training. Right. And then autonomic nervous and endocrine system mobilize extracellular substrate whereby these two things autonomic nervous system and endocrine system they increase carbohydrate and fat availability. This is physiologically what happen lah in our for our energy metabolism lah. We have two things. Of course kan kita ada autonomic dengan endocrine system lah. During the transition from rest to exercise, kita ada the sympathoadrenal system. And this system releases catecholamines and cortisol. This is more like autonomic nervous system lah. Kita ada dalam kita punya adrenal lah. Sympathoadrenal. This sympathoadrenal dia release catecholamines dengan cortisol. Ini kita panggil fight or flight hormone kan. This is more like a flight hormone lah in response in a quick response. Kita gunakan kita punya catecholamine dengan cortisol. Contohnya kalau you terkejut kan, anjing nak kejar kan, dikejar anjing ataupun dikejar hantu kan. So you ada apa? Kita akan guna kita punya autonomic nervous system. Dalam keadaan terkejut ni, takkan nak guna glukos kan, lambat. So apa yang kita buat, nak guna insulin pun lambat. So kita guna catecholamine dengan cortisol. Kita panggil flight hormone. Maksudnya in response to keadaan yang terkejut contohnya kan. Kita guna catecholamine dengan cortisol. And then generally during exercise, the arterial insulin level decreases. This one kalau kita based on kita punya tadilah, yang kedua tadi kita guna kita punya endocrine system lah. Kalau autonomic ni kita guna catecholamine dengan cortisol. Kalau endocrine ni by yang other means lah, by yang endocrine system, which is kita guna insulin dengan glucagon. Insulin ni kalau kita punya macam biasalah, when we have insulin being secreted kalau high level of glucose kan, kalau low level kita ada glucagon. Sama juga macam kita exercise, kita reducekan kita punya insulin, and then kita increase kita punya glucagon lah. Glucagon and growth hormone level increases. Why? To meet ataupun to supply the energy lah kan, to the exercising muscle. Kalau kita punya insulin tinggi, jenuh lah kita kan, kita tengok we cannot get the energy. Sebab apa? Energy tu being stored, kita tak nak disimpan, kita nak guna kan. So when we want to use the energy, we need a glucagon to liberate the carbohydrate, the glycogen and so on. Kita perlukan glucagon and growth hormone lah. Alright, and then the exercise induced increases in catecholamine concentration is able to stimulate tadilah. Ini yang tadi kita punya endocrine. Kalau kita punya catecholamine also be able to stimulate glycogenolysis, the breakdown of the glycogen kan. And then in the liver what happen? Kita produce new glucose, or we call it gluconeogenesis. Kalau muscle glycogenolysis, in liver gluconeogenesis. Neo ni new lah, production of new glucose. Yang ni pun the outcome kita akan dapat glucose kan, sebab kita break down the glycogen, and gluconeo pun kita akan dapat new glucose. Kita our liver lah produce glucose by other molecule lah. Kita guna protein, kita guna fat untuk produce a new glucose, and increase its availability in the skeletal muscle. And the idea is to supply lah energy to kita punya skeletal muscle. And at the same time, catecholamine also stimulates triacylglycerol catabolism. Triacylglycerol ni nama lain untuk triglyceride lah. Macam tadi kalau free fatty acid, nama lain dia adalah non-esterified fatty acid. Kalau triacylglycerol ni is actually nama lain bagi triglyceride. You ada 3 molecule of triacyl kan, triacyl. Lepas tu ada one molecule of glyceride. Samalah. Triacyl dia ada 3, ada one molecule of glycerol. Sebab tu nama dia triacylglycerol, or the other name is triglyceride. The same molecule, the same the same molecule with different name. Right? And then this will actually release non-esterified fatty acid, as I mentioned earlier on. Free fatty acid lah. Non-ester ni maksudnya dia free lah kan, free fatty acid. Bila you break down the triacylglycerol or triglyceride, you akan dapat 3 molecule of free fatty acid and 1 molecule of glycerol. So kalau fatty acid ni macam biasa lah kan, you akan guna untuk beta oxidation kan. You break down every 2 carbon untuk acetyl-CoA, and then glycerol ni 3 carbon kan. 3 carbon ni you boleh guna for the production of a new glucose kan, glycerol. Sebabnya glycerol ni 3 carbon. 3 carbon molecule glycerol ni 3 carbon molecule. Biasanya 3 carbon molecule ni it can be used to synthesize our glucose through gluconeogenesis in the liver. So glycerol ni dia akan pergi ke liver, glycerol ni plus dengan another glycerol, 3 carbon plus dengan 3 carbon, jadilah glucose kan. Glucose kan 6 carbon. So we can produce actually glucose from our glycerol lah. 2 molecule of glycerol for 1 molecule of glucose. Right. Okay, then the maintenance of blood glucose homeostasis during exercise is difficult because the rate of muscle glucose utilization increases several fold kan. Because we need to supply kan, the demand is very high, and intramuscular glycogen stores are rapidly consumed. So you tengok here, kita at the muscle lah kan, glucose tu digunakan dengan manifold lah, several fold increase, and at the same time kita punya intramuscular glycogen store tu depleted kan. Kita ni in general lah when we talk about glycogen stores, kita ada lebih kurang 400 lah 400 to 500 gram of glycogen. So you boleh kira lah, kalau glycogen ni 1 gram tu boleh produce 4 kilocal. So kalau you ada 500 gram, of you punya glycogen, you kali lah dengan 4. So lebih kurang 2000 kilocal lah yang you boleh guna daripada glycogen. So you can imagine kalau you buat more than that, habislah energy you, betul tak? So dia akan, you perlulah sumber lain, makanan tu ataupun the molecule tu. During exercise, the rise in glucagon level and the fall in insulin level both are important lah, like I mentioned earlier on. To increase, why? These two things we need to increase in hepatic lah, macam tadi lah. Through gluconeogenesis. Kalau gluconeogenesis ni mainly it happen in hepa. Hepa tu liver lah. Hepatic glucose maksudnya hepatic ni daripada hepa lah. Hepa means liver lah. And this is actually a key process in maintaining glucose release from liver over time. Maksudnya kita boleh sustain lah. Kita ada tadi tu yang first tadi kita ada apa? Kita punya glycogenolysis kan. Ini tak cukup biasanya. Kalau tak cukup, kena top up lah. Kena top up dengan gluconeogenesis daripada liver to support ataupun to top up kita punya energy tadi daripada kita punya muscle yang very limited tu lah, muscle glycogen. Cumanya glycogen ni not just from liver, not just from muscle. Glycogen juga kita ada some of it being stored in the liver. Maksudnya glycogenolysis berlaku dekat muscle and juga in the liver. Not just the muscle but also the glycogen tu can also come from our liver lah. But if you combine both sources, glycogen tu from muscle and our liver tu is around 500 gram sahajalah. I think this is already you already learn kan dalam kita punya nutrition for sport and exercise. We have those two things. Right, and then the increase in sympathetic nervous activity greatly increase oxygen demand and substrate delivery to the contracting muscle while simultaneously maintain blood pressure lah. These are the two things. Right. And then we look at the substrate utilization during exercise. And this was previously elegantly studied using a stable isotope. Macam mana kita nak buat? The best is kita tengok, kita guna stable isotope lah. Kalau tengok stable isotope ni kita boleh track. Kita boleh tengok kat mana isotope tu pergilah kan. Kalau kita nak bagi makanan ni susah. Makanan ni dia being, orang kata being metabolized. You cannot track. Sebab tu kita guna stable isotope. Sebab stable isotope ni macam dia macam orang kata apa lah, macam nuklear. Bukan nuklear, kata apa, sinar kan. Dia adalah isotope. Dia adalah radioaktif kan. Radioaktif ni tapi kita call it stable isotope. Stable isotope untuk study lah the rates of substrate utilization. It's very common. Biasanya kalau kita nak tengok study of substrate utilization, kita akan guna stable isotope study lah. To determine the rates of carbohydrate and fat oxidation at exercise intensities, kita bagi different intensity lah of exercise. 25, 65 or 85 VO2 max. Kita bagi different level. The higher the VO2 max ni, the higher the lung capacity lah. Kalau tengok kalau 25 ni mungkin you berjalan biasa saja kan. Itu 25 VO2 max. Kalau 85 VO2 max ni yang you tercungap-cungap tu. Yang you tercungap-cungap, main badminton dan sebagainya kan. You buat endurance. Biasanya sampai level 85 max lah biasanya. Right? And then we look at the lower VO2 max which is at 25. Kita guna apa? Kita guna non-esterified fatty acid. Sebenarnya kita guna kita punya fatty acid dahulu. Sebab apa? Sebab fatty acid ni dia dah available kan. It is readily available in our circulation. Sebab tu at 25 VO2 max kita hanya menggunakan kita punya kita hanya menggunakan kita punya fatty acid saja. So biasanya kita ingat kita guna glucose first kan. Sebenarnya at lower VO2 max, especially at 25, sebenarnya kita menggunakan free fatty acid first kalau ada lah dalam badan kita. Kita guna this free fatty acid first, then smaller contribution from plasma glucose oxidation. You tengok, at this level sebenarnya kita guna free fatty acid dulu, then secondary to the plasma glucose oxidation. Second source tu barulah datang daripada plasma glucose. This is bukan stored This is bukan stored yang bukan stored daripada glycogen ataupun daripada gluconeogenesis. This is when we talk about ada orang kata apa, those yang available lah from our plasma. So itu yang kita guna first kali. Right, and then 65 VO2 max. Alright, and then 65 at 65 VO2 max, it increase the utilization of the intramuscular stores or glycogen or triglyceride. So maksudnya at the 65 VO2 max barulah kita menggunakan kita punya glycogen or triglyceride. So maksudnya kalau nak kurangkan berat badan, kan nak buang all the lemak-lemak, you kena buat 65 VO2 max lah. Kan kalau you buat 25 je, you hanya menggunakan yang readily available dalam circulation. Kalau yang nak guna yang stored form, you kena buat 65 VO2 max, right? Okay, and then interestingly, it was reported that this intensity, the rate of fat oxidation was higher than either at 25 or 85 VO2 max. Sebenarnya lah higher at the 65 tu, higher than 25 and 85 VO2 max. Right, and then what happened at 85 VO2 max rely almost completely on carbohydrate utilization. Willis fatty acid oxidation contribute less than 30% of the total energy turnover. So this is how our body respond to different level of VO2 max. At 25 apa yang kita guna, at 65 apa yang kita akan guna, at 65 apa yang kita akan gunalah. Alright. I think ada yang saya tengok dalam chat ni ada yang ada kelas after this.
Yes, doktor.
Ya, kelas ada kelas dengan sains kom.
Kelas dengan Dr. Umi.
Kelas ganti ke?
Kelas betul.
Oh, kelas betul. Lambatnya. Petang Khamis Memang pukul 4 sampai?
Pukul 4 sampai pukul 5, 1 jam.
Oh, 1 jam.
Tutorial.
Oh, tutorial. Tutorial sajalah. You nak buat apa biasanya tutorial ada buat apa?
Sekejap lagi nak present assignment dekat doktor.
Oh, ya ke?
Untuk check.
Untuk check. Habis tu macam mana Ya, sebab kita mula lambat tadi kan. Sepatutnya kelas kita 2 kan. 2 to 4 kan. Memang you all punya time lah kan. Betul tak? Macam mana sebab nanti kan kesian pula dengan ni. Sebab you all semua student nutri saja kan. Half pula kan. Alright, so tak apa. So nanti untuk our class ni yang separuh lagi ni, yang tak habis ni, can we nanti kita continue macam